So we observe what is here simply V is proportional to I, valid only for metals. Is only metals obeying this law, right? So we have limitations for this law. What they are here, you are not able to apply this law for all the substances or all the materials. So that are called here limitations. So based on this, simply you are able to classify the materials into two categories that are obeying, right, and not obeying, right? Obeying and not obeying this law. So obeying materials are called as here ohmic conductors, which can obey this law. V is proportional to I, right? So the materials which can obey the Ohm's law, they are called as ohmic conductors, which do not obey that law called as non-ohmic conductors. So as you named as metals, conductors, so insulators. So likewise, here based on this observation, V is proportional to I, which are given that relation called as ohmic conductors, which do not give that are called as here non-ohmic conductors. So for ohmic conductors, we can give an example is any metal, all metals, right? All metals obeying Ohm's law. Then here non-ohmic conductors, simply non-metals, semi-metals, gases. These are example for non-ohmic conductors. So in limitations, we can write about ohmic conductors and non-ohmic conductors. Okay. Here you made observations using iron spoke as well as LED bulb, right? That you noticed already in your table. Respectively. So for V1, we are reading the current value as I1. For potential difference V2, reading the value as I2, V3, I3, V4, I4, V5, I5. So here you need to plot the graph, right, by taking those values on axes, right, on the axis X and on the axis Y. So here taking the values on x-axis, on the x-axis and on the y-axis. So scales you need to decide. So what are the quantities you need to take on the axis X and on the axis Y? So whatever it may be, you can take it. Whatever it may be, you can take it on axis X, on axis Y. Both graphs are possible. But in your 10th class, right, in our academic book, just only one type of graph is given. That is here simply the graph you are drawing here, voltage versus current. Voltage versus current graph. So that current you are taking on the axis X, sorry, axis Y here. Voltage you are taking on Y x-axis. So on the axis X you are taken voltage, on the axis Y you are taken current. In your intermediate level, you learn both graphs, right? That is here on the axis X you are taking current and on the axis Y you are taking voltage, right? In your intermediate level. So both are correct graphs only, voltage versus current and current versus voltage, right? So simply here you are following only this graph. What is that? Taking the voltage on axis X and taking current on axis Y, right? So this you are following here. Then here V1 value, So voltage you are taken 1.5 volts, 3.0, 4.5, 6 and 7.5. These are the values you are taken on the axis X. Then what are the values you are getting on current values? I1, I2, I3, I4. So that values you are giving as simply 0.5 amps, 1 amp, 2 amps, sorry, 1.5 amps, right? 2 amps, 2.5 amps. Actually, 1 ampere is high amount of current. These much values you are unable to get, right? Just blindly I am giving 3 like this, right? So here, if you plot the graph for a metal, you will get the curve as you see here, straight, right? For metals, you are getting the curve as straight, rectilinear. So rectilinear curve, that slope of this rectilinear curve always constant, right? So slope it will give you always constant, this black colored one. Then if you plot the graph using the values, you notice in case of LED bulb, that curve you will get like this, right? So if you find the slope, of this curved line, for this curved line, what you will notice here, this curved line slope is not a constant. Different values they will give you, right? So this you need to observe through the graph. So look at that graph, right? This is the graph you are getting between voltage and current, voltage versus current graph, right? So you will get for iron spoke or any metal, if you are observing that in case of semi metals, right, you will find this graph as ascending curve, right? What is ascending curve? Non-linear curve. Simply you can name it as also non-linear curve. So these are the graphs. From the graphs also you are able to decide whether it is ohmic conductor or non-ohmic conductor. So rectilinear curve, if you observe, that is here ohmic conductor. If it is non-linear curve, that is simply called as non-ohmic conductor. By the graph also you are able to decide it is ohmic conductor or non-ohmic conductor, or is it obeying or not obeying the Ohm's law. What is Ohm's law? V is proportional to I. If you remove this proportionality constant by that ratio, you will get a constant always. That constant value is given as R here. That R is what here? Simply that R is here named as nature of the material. Nature of the material. What nature? Consumption means obstructing, right? It can obstruct the flow of charges, collisions, right? Collisions. So obstructing nature only called as here this constant given as R. So that was named as nature of the material, simply resistance, controlling the motion of charges. That obstructing nature of the material is called as resistance. So we got a new concept from the Ohm's law, that is nature of the material is playing an important role, that is given as here resistance. Are you clear about these things? What we learned from Ohm's law? We got a new idea, that is about resistance. So if you are clear, we'll end this session for today. Tomorrow we'll start with that resistance and electric shock. So everyone, just go to quick reaction immediately. If it is clear, we will end this session. So everyone is clear. Thank you. We'll meet tomorrow at same time with a new topic, that is electric shock. Right? So join by 6 a.m. in the morning. Thank you.